Welcome to AP Daily, AP Computer Science Principles, Topic 3.8 Iteration, Video 1. My name is Bradley Bearden, and I teach computer science in Dadeville, Alabama. And I want to invite you to invite a friend to take a computer science class. What will we learn today? Today, we will look at express an algorithm that uses iteration without using a programming language. And remember that iteration is the repeating part of the algorithm. So sometimes we call it a loop. So it's the part that repeats. So here's an example of what that might look like in in an algorithm. In a flow chart, sorry. You'll notice that it loops until the condition is true, and then it makes its way out of the loop. So let's take that and let's look at an example. Suppose that we're online shopping and you go to your favorite website and you're looking and you search and you click on a product. So maybe what's important to you is, does that product have good reviews? So what are you going to do if the product doesn't have good reviews? What are you going to do if that's false? Well, maybe you'll look at the reviews and you'll adjust your search. I know sometimes when I've looked at things that they've helped me adjust my search so I could find an item that maybe I did like. All right. Then you click on that different product. So what are you going to do? Well, you're going to ask that same question again. Does the product have good reviews? So notice I loop back around to that question, that sort of condition. And this might be something that you go through over and over and over more than once, right? It may happen many times that you can't find any good products that have the reviews you like. But what do we do if we do find a product with a good review? You don't just immediately go purchase it. You really need to ask yourself, can you afford that product? And what do you do if the answer is not true? What if it's false? Well, what probably adjust our search again, click on a different product, and we'll start the process back over again. And so you can see the iterations of the loops that are happening here. And again, it might be several times before we find one that meets both conditions. And then when it's true, then we'll purchase our product. So here's an example of an algorithm that uses iteration. So let's take a look at a second example. Suppose that we're trying to find a lost item at home. And now you're confident, because I know this happens to me a lot, that like, did I leave it at home? Did I leave it somewhere else? But let's just say you're very confident that you left it at your house. So what steps might we take? Well, I gave you a little starter idea there, which is if you got N rooms to search, go ahead and number all the rooms 1 to N. And then start with room 1. And you're going to search that room thoroughly for your item. And then we'll change our room to the next number. And just like I know everyone's done this. So you go to the next room and you just search it, trying to find that item. And we're going to repeat steps 3 and 4 until you've searched everywhere. Okay. And then you can enjoy your lost item. But this algorithm has a small problem. What if when you search the room, even like maybe the first room that you went and searched, what if you found the item? Well, according to this algorithm, you would have to keep searching all the rooms until you found your item, but you've already found your item. So a good idea when doing iteration is to have what we call a stopping condition. And so in this example, the stopping condition might be, if you find your item, skip to step 6. And that will allow you to get out of the loop and move on to the next part. All right. So now we are going to practice. Suppose that there are 367 people in a room. Now, if that's the case, then 2 people are guaranteed to have the same birthday. So I want you to think about why. But how can we find 2 people with a common birthday? So I want you to pause the video and maybe collaborate with a partner if needed, and try to write down an algorithm that would let 2 people, or find the 2 people that share a common birthday. Now, as you're doing that, I want you to think why this algorithm would require iteration. So I want you to pause the video, work on that, and see if you can come up with one that works. How'd you do? Well, let's just take a look at one way in which you might could do this. So if you may not have 367 people in your room, but maybe I would suggest that if you had a couple people in the room, you might act this out, right? Kind of have people stand up and act it out as we go. And that could help you figure out kind of what's going on. So let's say we number everybody in the room from 1 to 367, and we put them in a line. Now, we're going to make person 1 the questioner. That's the person that's the questioner is going to be the person that asks other people if they have the same birthday as them. And then the person with a number 1 greater than the question will be the starter. And that's the person that you're asking the question to. So the questioner will ask the starter if they have the same birthday. And then what we need to do is not just ask that person, but we need to ask everybody else in line. So we'll make the person 1 greater than the current starter, the new starter. And we will repeat steps 4 and 5 until that questioner has asked everybody in the line with a greater number than them. Okay, so that's just right now, that's just person 1 has asked everybody in line, but person 1 might not share a common birthday with everybody. So maybe we'll have to keep going to try to find those that share the common birthday. So we're going to make the person 1 greater than the current questioner the new questioner. So that if person 1 was the questioner before, now person 2 is going to be the new questioner. And so now we're going to go and we're going to repeat steps 3 through 7. So that will allow the new questioner, person 2, to go down the line and ask everybody if they share the same birthday. And if person 2 doesn't match, then we'll have to go on and try person 3 and person 4 until we find the match. And when we do, we can just let them go have a party. But just like before, we really need to put a stopping condition in there so that once we stop, we don't have to keep going. So think about, where would you put the stopping condition? I hope you said line 4, which is when they ask if they share the same birthday. If they share the same birthday, skip to step 9. So what should we take away? Well, you need to be able to express an algorithm without a programming language. So that might be pseudocode, or not pseudocode. That might be a flowchart, or that might just be natural language. So, and also, iteration is the repeating part, or a loop. And so you need to be able to express algorithms with iteration. Thank you.